So it's Thursday afternoon, we're at the TCT show, 3D printing event here at the NEC in Birmingham. We've been here for the last 2 days. We're going to have a walk around, haven't we, Gio? Show
yeah,
some
let's
of the
go and
highlights.
find out what's been going on. This has been a fantastic show. It's absolutely mind-boggling.
3D printing first was kind of invented, I suppose, back in the 1980s. That was the FDM process, but things have moved on so much, certainly since the turn of the year 2000. Here's our first stop, available from Kingsbury, these machines. Gio, you know a little bit more about the adult.
Yeah, the adult machine is a production machine. This is not for R&D, this is for production. For metal components, it's reliable, fast, can run 24/7. And if you want to find out a little bit more about this machine, contact Kingsbury in the UK. This is just one example of some of the machines available, some of the technologies that are available here at the TCT exhibition.
Metal printing is a big thing at the event this year.
People of metal printing now, it's gone up to 36% in the UK in comparison to 28% in 2017. So
36% of machines bought are for metal printing.
For metal printing now, so it's really lending itself to some applications.
And once you printed a part, you may need to machine it as well. And that's normally a second process. But here on the Sodic stand, this is the OPM machine. The second process of the subtractive side, the machining side, can actually be done on this machine. So it's basically one cell where you can do the addition of the material and the subtraction. Benefits to that: precision parts. You're doing everything in one machine. The integrity of the component, I suppose, the speed of manufacture.
But you can also really think out the box in regards to designing components that you've never could design before.
Yeah, absolutely.
You know, it's really re-engineering.
And that's from one end to the other as you move across the hall here from Ultimaker. Some of these machines here, we're told, around about 200 companies here exhibiting at the show, and most of them are showing kit like this. Now, this is what you would probably not class as an industrial product. This is something that you could use at home, maybe, Gio, to make your models.
Exactly, and even for prototyping like this, you know, any kind of components that, you know, this is from an actual steel component here that's been 3D printed, so it really just illustrates the kind of stuff that you can do with entry-level machines all the way up to...
Not often we also come to a show as well where you can buy machinery for less than £1,600. That's what one of those machines is. I've got to say, I'm not sure about this technology here, but it looks like we're combining routing with lasering. So, as I say, not quite sure on the technology, but it just show you the diversity, the types of machines that are on show here.
A 3D printed dress.
Oh, look at that!
Well,
we've got a Christmas do coming up. Gio, your wife could maybe you could make her one of those.
I won't be able
That
to
just shows you
afford.
to the extent of what people are thinking. It's about thinking outside of the box completely.
Here are some lovely components, Paul. So if a component like this has been made in one hit, 3D printed, and you know to do this in one hit, how would you have done that? On a traditional.
Correct, it would be a casting, wouldn't it? But yeah, I mean, that's what this is about. Even things like here, spectacles. It's like people are trying to think of the most diverse and crazy almost products that they can make just to show off what they're capable of.
I was speaking to a gentleman yesterday that had pretty much an instant return of investment when he purchased his first 3D printer, and this is a common theme. Talking to the people at the show.
And also another fact which is really interesting, that NASA are actually now starting to use 3D printing in space. And you might think, well, why are they doing that? What are they doing it for? Well, they're taking robots up to space and then they're going to print things for infrastructure. So maybe even things as crazy as hotels or buildings, they're going to print them as opposed to taking them up. That's just how far 3D printing has come.
It's a nice component here, Paul.
Yeah, again, classic application here. This is actually plastic sintering as well. So this is where you get a better definition of part, better finished part, better integrity, stronger, as good, I'm told, as an injection molded component.
What different ways of 3D printing are there, Paul, do you know?
So many different ways. FDM, SLS, SLM, SLA. Here's a classic component. Absolutely love this. this is a really good example of where things have moved. This is a combi burner. We're actually on the Trump stand here. This is obviously for a domestic use, go in a boiler, but they basically designed and engineered this so it's the most efficient in production. So basically, you've got all your cooling channels. It's been totally rethought from the ground up. Now people might say, okay, well, it looks like an expensive part to make, but if it can save you £10 on your heating bills, or maybe even a few of your expensive jumpers, Gio, it's got to be worth it, isn't it?
I like the applications and the components on the Trump stand. They're real life examples. There's a lot of medical components there, and there's some other great examples on this stand here. This component here is another real life example that they're actually using on the CNC machines. It's a bracket for the machine, and it was machined before.
We all know XYZ for supplying metal cutting machines. Obviously, they're now one of the resellers for HP. Two gentlemen behind us, I'm sure, have had a busy week. Looking forward to the end of it. That part, as Gio said, is actually being printed, and it will go onto their machine or onto a machine in production. So again, not everything these days needs to be made from metal. It can be made. Some of these components have the strength and the integrity of metal parts. They're lighter and they're engineered in different ways where you can engineer them obviously to suit what you need. I think as we move into this area, we start to see a lot of what looks like common machinery, quite small printers. I mean, take a look at what we're sort of printing here. Typically, this is almost like a twin spindle.
It is, yeah. I've not really noticed this before, so I'm presuming that you have 3D printing farms, don't you here, Paul, where you
Euros,
have banks and banks of these machines printing components.
Doubling up your production, and you sometimes think to yourself, well, how do you go about the design of these? Well, a young lady was telling me earlier that actually there's two main systems. Two main kind of like online systems where you can go in and they've got a range of parts and sizes, and you manipulate them, put your names on, put your text on. It's dead simple. Export it onto a USB, plug it into one of these machines, and you're away. And in fact, one of the machines she was telling me about was just 120 quid.
I think one thing about 3D printing as well is that you can really customise components and re-engineer components, make a lot of one-offs and make things unique.
And we can't not obviously talk about the show, because that's what we're here. There's been over 35 presentations this week that have happened here on 3D printing technology. Also, it's also not just about the machines and the people providing the services. What about the materials and the consumables? That's all here as well, and the metrology. The metrology,
but also the how do you program the parts? How do you get the programs into the 3D printers? We've got scanners here, a scanner from Zeiss, for example. You can scan these parts, you can re-engineer parts, you can do pretty much, manufacture pretty much anything that you want. And reverse engineering is a really big feature with some of this scanning technology.
Check out these. That's Gio's, that's mine. All printed. This was the original casting here, in fact, which they scanned and then they printed, and this is the one that they've actually printed. You can see that there. That is a classic piece of reverse engineering, just rescaling.
Talking about scales, I've noticed, Paul, that the machines are coming in lots of different sizes, and this is one of the most. It's the largest one that I've seen here at the show.
If we had a top 5 highlights, this would have to be definitely one of them. Look at this machine, brand new to the UK. This is using the fused deposition. This is the FDM process. This machine is actually £50,000. But just imagine where you'd use this.
Lots of different applications, and there's some examples there of the automotive industry, aerospace industry,
in fact, let's go and
art industry.
You can imagine if you were operating in the theatre, or you're looking for props. This is exactly where this type of machine is useful. And you've got the smaller version here. This machine, or the one we started looking at, will actually go up to just over 2 meters in height. So if you were in the arts industry, and before you might have had to have waited 2 weeks to order something like this, it looks like me.
A bit taller than me.
Nowadays, you can literally print it, and that has actually been printed in less than 2 days so far. It's taken 2 days to print that. So, talking about fast turnaround times, that's really where that machine fits. Like I say, £50,000 in the UK, incredible piece of technology. This is one of the machines I was looking at. It's from huge to. This is the machine's £120. Ideal for the kids. I mean, fantastic. How How much fun and educational is that? And that's where you can go on the internet, you can look and manipulate parts, put them on a USB stick and actually
It's a
print.
good way to recycle plastic as well. You know, we've got a big issue with recycling.
And
It's a perfect
these have
way.
been printed as well. You wouldn't believe it that they've been printed.
Even smaller 3D printer here, Paul.
I even like the name, Be the First.
Every component can be unique. Every component can be an absolute one-off, can't it?
And look at for schools. Again, perfect educational example. Look at this. And one in action. Now, of course, this type of machine isn't going to give you the ultimate in precision, because you are just layering essentially melted plastics. But when it comes to, you know, working on parts just for aesthetics, you know, like we said, domestic use is perfect.
But you've got to start from somewhere, haven't you, Paul? You know, when fifth axis machines first came into play, you know, you dabbled in with a fourth or fifth axis rotary table, and you've got different levels, haven't you? And it's kind of, this show's really kind of illustrating people that, from hobbyists all the way to multi-million-pound companies.
Printing time on this, 153 hours with a 1mm nozzle. Just 153 hours. So you start to think, when does prototyping turn into production? Where is the
crossover?
We hear a lot about parts that are now going into, or potentially being used in the aerospace industry. Okay, well, I keep hearing this potentially, but when is it actually going to become a reality? There's obviously a lot of testing that needs to go on to get your approvals. Here's another example that we've looked at: tooling, jigs and fixtures. Predominantly you might have been looking at end user components. Here we've got medical parts, but what about beyond this, Chris? If you have a look there, you'll just see fixtures.
There's some of the benefits there. The reduced weight, the reduced time to manufacture it, the reduced cost. There's massive savings to be had in all different areas.
And a lot of the plastics that are being printed these days do have the strength and the integrity of injection mold parts, so you don't need to make a tool. You can basically print the components immediately, giving you instant results. And it does look like, as you walk around the show, that there is a lot of machines that are similar, but applications are key. Check out this one to my left here, or to our left here. This is typically a way of saving material, isn't it?
Absolutely, and it still kind of needs CNC machining, subtractive machining. These two technologies can work in harmony, and it's all about embracing both technologies and to become the best and the most efficient that you can possibly be.
That's been layered up. Then you'd machine it the second process earlier, but as we said earlier, there are machines such as the Lumex, for example, from Matsuura, which can do both of those. I was on the SYS stand yesterday. They sell the Stratasys machines, and I was talking to Rob, and he was telling us about some of the parts that they are using these days, or looking to use, or capable of being used within aircraft, trying to get approvals for the materials and things that are being printed that have now that are heat resistant enough to be able to withstand critical parts on aircraft. And that is something that these businesses are really moving into. I think really that pretty much concludes it from us here at TCT. It's been a tremendous show. It's been a real learning curve. We'll definitely be back next year, and if you hadn't had a chance to get here this week, then hopefully this has given you an insight as to what is here. The show will be on again next year.
Absolutely brilliant show.